Okay, I'm going to look at binomial probability distributions in 5.2 and go over some of the homework problems, and hopefully this will help us with one of the most confusing things we've covered in class so far. First, we are being asked several times to look at an experiment and determine whether it represents a binomial distribution. Here's an example in question 5. An experimental drug is administered to 30 randomly selected individuals with a number of individuals responding favorably recorded. And so we need to determine whether the following experiment represents a binomial experiment. So let's look at the definition of a binomial experiment. We need a fixed number of trials, and the trials need to be independent. Well, here we have 30 randomly selected individuals. Each one is a trial, and we're assuming that their reaction to the treatment will be independent, and that each trial has just 2 outcomes. Here, we want to see whether they respond favorably. So 2 outcomes, they can either respond favorably or unfavorably. So that is met. And then is there a fixed probability of success? An experimental drug is administered to 30 randomly selected individuals with the number of individuals responding favorably recorded. I think here they are assuming there is going to be a fixed probability of success with the treatment. So let's see if this is saying that it is a binomial experiment. Yes, because the experiment satisfies all the criteria of a binomial experiment. The criteria, these 4 listed here. So not a perfect question because it doesn't actually give us a probability of success, but I'm thinking that because they are saying that they're all taking the same drug, that the probability of a favorable outcome would be the same. All right, so at this point I want to look at some of the examples of finding binomial probability, and I want to try to do this in a word problem format. So I'm going to look at question 14. It says, based on a poll among adults who regret getting tattoos, 17% say they were too young to get tattoos. Assume that 4 adults who regretted getting tattoos were randomly selected and find the indicated probability. Okay, so part A says find the probability that none of the selected adults thought that they were too young to get tattoos. So if it's the probability of none, that is the probability of exactly 0. So this is an exactly probability. The probability of none of the adults is the probability of exactly 0. So if we go to our notes and we look for the probability of exactly x, we're going to use the binomial distribution, the number of successes, the number of trials, the probability of success, and 0 meaning not cumulative. So the probability that none of the randomly selected adults thought they were too young would be the probability of exactly 0. Let's look at our n, our p here. Our n is going to be 4. So there are 4 trials. You go ahead and put n equals, and then I'll put the 4 over here so I can use it. Our p, the probability that they thought they were too young, that is 17%. So 0.17. And our x is going to be changing throughout the problem. So let's use an x of 0 for part A. Okay, so I'm going to go ahead and put in my binomial distribution, my n, my number of successes. That's my x. So I'm going to put in my x first. Then I'm going to put in my number of trials, my n. Then I'm going to put in my probability of success, and then a 0 for not cumulative. So we're saying that the probability that none of them thought they were too young is 0.4746, rounded to 4 decimal places. Okay. Now, one of the things that you can do, this one on B says find the probability of exactly one selected adult thinking they were too young. So this is still an exactly, and the way we have it set up here where we're selecting these boxes, now if we want the probability of exactly 1, if we just change our x from 0 to 1, that changes our probability, and it changes it to 0.3888. So let's see if that is correct. Okay. Find the probability that the number of selected adults that thought they were too young is 0 or 1. Now, one of the ways that you can look at this is the probability of 0 or 1 would be the probability of 1 or fewer. So we can go down to the probability of x or fewer. The probability of x or fewer, and we actually do want the probability of 1 or fewer. So in that case, the probability of 0 or 1 is the probability of 1 or fewer. X is less than or equal to 1. We can just put in our 1 for our x, our n is still 4, our p is still 0.17, and cumulative. So the probability of 0 or 1 would be the probability that x is less than or equal to 1. Let's try it. One or fewer out of 4 with a probability of 0.17, and we want it to be cumulative. So 1 or 0 would be 0.8634. Now, here's an interesting question. If we randomly select 4 adults, is 1 a significantly low number of adults who say they are too young to get tattoos? Now, significantly low or significantly high means that the probability of that number or fewer happening is going to be less than 0.05. But if we look at the probability of 1 or fewer, it is 0.86, so it is not less than 0.05. If we randomly select 4 adults, is 1 a significantly low number of adults? No, because the probability that at most 1, which is the same as 1 or fewer, so at most 1 of the selected adults say they're too young, is actually greater than 0.05. So this is not a significantly low number because the probability of at most 1 of the selected adults thinking they're too young is 0.8634, which is greater than our 0.05. Now, here is another word problem. The probability of a randomly selected adult in one country being infected by a certain virus is 0.002. In tests of the virus, blood samples of 20 people are combined, and the probability that a combined blood test, what is the probability that a combined blood test is positive for the virus? And then is it unlikely that such a combined sample will be positive? Now, they do say that a combined sample is positive if at least one person has the virus. So here is a problem that is asking us about at least one. So this is an at least probability. Okay, so we have a n of 20 and a p of 0.002. Okay, so let's find the at least in our notes. Here it is, and we notice that this is the one we're going to use the complement for, because really what they're asking is that the probability of x is greater than or equal to 1. Okay, and so, which is the same as the probability that of 1 minus less than or equal to 1. So we're going to use the complement here of at least 1. So let's try it. Our n is the number of samples that we put together, which is 20 in this case. Our p is the probability of a positive test result, which is 0.002. Remember, success doesn't mean something good here. It's just what we define as success. And what else do we need? Our x is going to be 1. All right, so let's go ahead and try it. Equals binomial dist. Let's see, x minus 1. Sorry, going all over the place here. X minus 1, comma, n, comma, p, and we do want it to be cumulative. So we're looking at a 0.96, and that is wrong. I know that that can't be right because that's way too high for a positive test result when our result is, when our probability of a positive is 0.002. So I'm not going to put that in. I'm going to look again at my formula, and I'm going to see, oh, I forgot that I need to do the complement of 0.96. So I'm going to just put here a 1 minus, and that will give me the correct answer, I believe, 0.0392. So rounding to 3 decimal places, 0.039. Okay, so that was an at least 1. When you do at least, you want to do 1 minus x minus 1 n p and 1. Is it unlikely that such a combined sample will be positive? Well, we're comparing it to 0.05, and 0.039 is less than 0.05. So it should be unlikely for such a combined sample to test positive, because the probability is less than or equal to 0.05.